At A-level in maths and physics, everybody loves a good suvat projectile motion question. Here we've got an L16 81mm mortar, and it's going to fire a bomb something like this. So there's going to be this parabolic path between where it's launched and where it lands. I want to calculate how far the mortar bomb will travel horizontally before it hits the ground, assuming, of course, there's going to be no air resistance. So the first thing I'm going to do is write down suvat. And I'm going to say at this time, upwards is my positive direction. And I'm just going to consider the first half of the journey from the initial point over here until it gets to the maximum height. Now, we don't know what height it is, but we know that its initial velocity in the vertical direction is going to be equal to 225 at an angle of 70 degrees to the horizontal. So I'm just going to mark that in here. So that's 70 degrees. This angle, and therefore it's going to be this vertical component of velocity that we're interested in. If that's 70, then we're going to use sine 70 degrees, and if I just work that out, this is equal to 211.43 meters per second. At the top, its vertical component of velocity is going to be 0 meters per second, and the acceleration is going to be minus 9.81 meters per second squared. Okay, it's minus because we're saying upwards is positive. We don't know how long that takes, but we can use this to work it out. We can say that this time is equal to v minus u over a. We can put the numbers in, we can work it out on our calculator, and this gives me a time equal to 21.55 seconds. So if it takes 21.55 seconds to get to the top, it's going to take another 21.55 seconds to get down to the bottom. And now what we can do is maybe consider the motion in the horizontal direction. We don't know how far it's gone, but we know the speed it's travelling at is going to be equal to 225 cos 70, and we know the time it takes is going to be twice that. So if I just multiply that by 2 on my calculator, that's equal to 43.105 seconds. And now that distance it travels is going to be equal to its horizontal component of velocity multiplied by the time taken, which equals 3,317 meters, which is approximately equal to 3.3 kilometers. So this one over here, we've looked at the vertical velocity independent of the horizontal velocity, done some maths, and got a range of about 3.3 kilometers.